Welcome to session 8 of our systematic review module. So we're now in the second week of the sessions on data extraction and risk of bias. And today we're going to be focusing on risk of bias. Each week I've been highlighting to you skills that you should be able to add to your CV after you've completed the action points for each session. After you've completed this week's action points, you'll be able to say that you're confident in undertaking data extraction using a methodological expectations of Cochrane Intervention Review's data extraction form, and that you can reliably make risk of bias judgments from study reports. To undertake this week's action points, I'm assuming you've done action points from the previous weeks. As well as the title and abstract screening, I'm assuming that you've completed the following: that you've confirmed how you will operationalize full text screening, that you've retrieved the full text for the records that have passed title and abstract screening, that you've split screening by pairs and then shared and undertook the full text screening, and then once this was done, reported agreement using percentage agreement in and out, and reported the first reason that records did not meet the eligibility criteria. I'm assuming that you've resolved disputes across the review using Disputatron. As such, you should now be at a stage where you know how many records you will undertake data extraction upon. Now, you may have found that there is some variation in the outcomes that are available in the studies that have passed full text screening. And if that's the case, there's not a clear primary outcome for your review to focus on, and you need to discuss what the limits are to eligibility for use in your review. And certainly, where there's more than one potential outcome for any single study, you need to have explicit rules on what you will use. And you'll remember I discussed this last week. You need to make sure that you've amended the MECIR data extraction form as we discussed last week, and that your supervisor is happy with the amendments. Finally, you should have double extracted at least one paper as a whole team so that you can calibrate your approaches. Do look through what you've collectively done and where there are ambiguities, and add guidance to your forms. So you remember from last week, garbage in, garbage out. The extent to which a review can draw conclusions about the effects of an intervention depends on whether the data and the results from the included studies are valid, and that the evaluation of validity of included studies is therefore an essential component of a review and should influence the analysis, interpretation, and conclusions of the review. You remember the work of Schultz et al. From 1995, where they examined 33 meta-analyses containing 250 clinical trials and looked at whether sequence generation was reported to have a random component, whether allocation was reported to be adequately concealed, whether the trial was described as double-blind, and whether the trial reported exclusions of participants from its analyses. Finding there that odds ratios were exaggerated by 41% for inadequately concealed trials. The authors summarised their findings saying, "Our findings not only highlight the importance of adequate methodological quality in controlled trials, but also the importance of complete and reliable reporting. Without adequate reporting, assessing quality becomes impossible. Authors should, as a minimum, explicitly describe their approaches to sequence generation, allocation, concealment, blinding, and handling of exclusions after allocation. Preventing foreknowledge of treatment allocation by effective concealment of allocation schedules in controlled trials emerges from our analyses as crucially important to reducing bias. Without proper application of measures to achieve concealment, the whole point of randomization vanishes and bias is likely to distort results." The Cochrane collaboration recommends a specific tool for assessing risk of bias in each included study. The original tool for assessing risk of bias in randomized trials has been widely cited with over 40,000 citations in Google Scholar. However, assessment has found that more guidance on incorporating risk of bias assessments into review conclusions is needed, and that some bias domains can be confusing. Empirical studies have found only moderate reliability of risk of bias judgment. Risk of bias 2 is structured into a fixed set of domains of bias, focusing on different aspects of trial design, conduct, and reporting. The domains are as follows: 1. Randomization process. 2. Deviation from the intended interventions. 3. missing outcome data. 4, measurement of the outcome. 5, selection of the reported result. Each assessment using the Risk of Bias 2 tool focuses on a specific result from a randomized trial, so it's by outcome. Within each domain, a series of questions, signaling questions, aim to elicit information about features of the trial that are relevant to risk of bias. Answers to signaling questions and judgments about risk of bias should be supported by written justification. The overall risk of bias for a result is the least favourable assessment across the domains of bias. To maximise the signaling question's simplicity and clarity, they're phrased such that a response of yes may be indicated of either a low or a high result of bias, depending on the most natural way to answer the question. Responses of yes and probably yes have the same implications for risk of bias, as do responses of no and probably no. The definitive versions of yes and no would probably imply that firm evidence is available in relation to the signalling question. Probably versions would typically imply that a judgment has been made. No information response should only be used when 1, insufficient details are reported to permit a response of probably yes and probably no, and 2, in the absence of these details, it would probably be unreasonable to respond probably yes or probably no in the circumstances of the trial. For example, in the context of a large trial run by an experienced clinical trials unit, absence of specific information about generation of the randomization sequence in a paper in a journal with rigorously informed word count limits is likely to result in the response of probably yes rather than no information to the signaling question about sequence generation. The implication for risk of bias judgments of a no information response to a signaling question differ according to the purpose of the question. If the question seeks to identify the evidence of a problem, then no information corresponds to no evidence of that problem. If the question relates to an item that is expected to be reported, such as whether any participants were lost to follow-up, then the absence of information leads to concerns about there being a problem. For signalling questions that are answered only if the response to a previous question implies that they are required, a response option not applicable is available. Signalling questions should be answered independently so that the answer to one question should not affect the answer to other questions in the same or other domains other than through determining which subsequent questions are answered. I should add, there is space for free text alongside each of the risk of bias judgments to explain the reasoning that underpins that judgment. It's particularly important that reasons are provided for any judgments that don't follow the proposed algorithms. So that was a lot of information. Practically, what you need to do is, at the first step, go to riskofbias.info. Once you're there, click on the Risk of Bias 2 tool link on the sidebar on the left. That'll open up. Then select the current version of Risk of Bias 2. Click on that. That will open up, and you can then select current version of Risk of Bias 2. Click that, and you'll then see that there are 3 versions. Current version suitable for individually randomized parallel group trials, which is what I believe the vast majority of you will be using. A test version for cluster randomized trials, which some of you, if you're looking at cluster randomized trials, may use. And lastly, a test version for crossover trials, which I don't believe any of you are going to need. When you click on the current version, you're offered the full guidance document, the crib sheet summarizing the tool, a template for completing the assessment, an Excel tool to implement Risk of Bias 2. The 2 that I think are most helpful and which I've pinned at the top in the Files tab are the crib sheet, because it contains guidance for each of the signaling questions, and the macro, because not only is it just as easy to complete as a template, it creates the pretty figures that you're going to want for your reviews. So download the crib sheet and download and open and enable editing and enable content on the macro. And you can run the macro. This is important. You'll see the tabs at the bottom, other than the intro tab, they contain nothing until you run the relevant macros. Okay, so the next steps are to start keying in the data. Once you've opened the file, enabled editing, enabled content, you will need to click on the big Risk of Bias 2 assessment button. Once you do that, a large dialog box will open. The first section is all about identifying the record you're making judgments about. So you need to give it an assessment ID. Give each assessment an assessment ID and enter this in the relevant space on the form. The assessment ID can be letters, numbers, or a combination of both, and it's used to identify a specific risk of bias assessment. Given Risk of Bias 2 is an outcome-based assessment, I recommend you have a naming system incorporating the outcome. This will be used to match assessments done by your paired reviewer in the Discrepancy Check function, and then add your initials as the assessor ID. If you've created separate IDs for studies that the report relates to, enter that here. If not, use the same one from the final group in your EndNote library that contains the full text of past screening. Give the in-text citation in the ref or label box and specify clearly what outcome you're judging. Remembering, risk of bias judgments are by outcome, so it's vital that it's clear what outcome you're referring to. Specifying the numerical result is there to support this. In the case of multiple alternative analyses being presented, specify the numeric result and/or a reference, e.g. to a table, figure, or paragraph that uniquely defines the result being assessed. Next, we have to select the purpose of the review, and in our case, it's always assignment to intervention, the intention to treat effect. Assuming we're looking at the macro, we have the option to weight the influence of the report. This is set by 1 to default. Each result has equal weight, but can be edited to reflect the weight given to the result. And this can be added by sample size. So just enter the size of the sample there. This is only relevant for plots created by clicking the summary button in the intro sheet, which I will explain later. However, note that the weights should be entered in the same format for all studies, e.g. a decimal or a percentage. Next, you're asked to tick as many as apply which of the following sources were obtained to inform risk of bias assessment. So tick all the ones that you've used. Then you're on to domain 1. 1.1, was the allocation sequence random? In the crib sheet, the elaboration says, answer yes if a random component was used in the sequence generation process. Examples include computer-generated random numbers, reference to a random number table, coin tossing, shuffling cards or envelopes, throwing dice or drawing lots. Minimization is generally implemented with a random element, at least when the scores are equal. So, an allocation sequence that is generated using minimization should generally be considered random. Answer no if a random element was used in generating the allocation sequence or the sequence is predictable. Examples include alternation, methods based on dates of birth or admission, patient record numbers, allocation made by clinicians or participants, allocation based on the availability of the intervention, any other systematic or haphazard method. Answer no information if the only information about randomization methods is a statement that the study is randomized. In some situations, a judgment may be to answer probably no or probably yes. For example, in the context of a large trial run by an experienced clinical trials unit, absence of specific information about generation of the random sequence in a paper published in a journal with rigorously enforced word count limits is likely to result in a response of probably yes, rather than no information. Alternatively, if other contemporary trials by the same investigator team have clearly used non-random sequences, it might be reasonable to assume that the current study was done using similar methods. Now, you have to choose between yes, probably no, no, and no information. Remember, responses of yes and probably yes have the same implications for risk as bias as do responses of no and probably no. So yes and probably yes are the same, and no and probably no are the same to all intents and purposes. The definitive versions, yes and no, would typically imply that firm evidence is available in relation to the signal in question. The probably version would typically imply that firm evidence is available in relation to the signal in question. The no information response should only be used when both insufficient details are reported to permit a response of probably yes or probably no, and in the absence of these details, it would be unreasonable to respond probably yes or probably no in the case of that trial. The next question is 1.2. Was the allocation sequence concealed until participants were enrolled and assigned to interventions? The crib sheet says, answer yes if the trial used any form of remote or centrally administered method to allocate interventions to participants, where the process of allocation is controlled by an external unit or organisation independent of the enrolment personnel, e.g. independent central pharmacy, telephone or internet-based randomization service providers. Answer yes if envelopes or drug containers were used appropriately. Envelopes should be opaque, sequentially numbered, sealed with a tamper-proof seal, and opened only after the envelope has irreversibly been assigned to the participant. Drug containers should be sequentially numbered and of identical appearance and dispensed or administered only after they have been irreversibly assigned to the participant. This level of detail is rarely provided in reports, and judgment may be required to justify an answer of probably yes or probably no. Answer no if there is reason to suspect that the enrolling investigator or the participant had knowledge of the forthcoming allocation. Again, have to choose between yes, probably no, and no or no information. The final signalling question is 1.3. Did baseline differences between intervention groups suggest a problem with the randomization process? The crib sheet says, note, differences that are compatible with chance do not lead to a risk of bias. A small number of differences identified as statistically significant at the conventional 0.05 threshold should usually be considered to be compatible with chance. Answer no if imbalances are apparent or if any observed imbalances are compatible with chance. Answer yes if there are imbalances that indicate problem with the randomization process, including substantial differences between the intervention group sizes compared with the intended allocation ratio, or a substantial excess in the statistically significant differences in baseline characteristics between intervention groups beyond that expected by chance, or imbalance in one or more key prognostic factors or baseline measures of outcome variables that is unlikely to have been due, or very unlikely to be due to chance, and for which the between group difference is big enough to result in bias in the intervention effect estimate. Also answer yes if there are other reasons to suspect that the randomization process was problematic. Excessive similarity in the baseline characteristics that is not compatible with chance. Answer no information where there is no useful baseline information available, e.g. abstracts or studies that only reported baseline characteristics of participants in the final analysis. The answer to this question should not influence answers to questions 1.1 or 1.2. For example, if the trial has large baseline imbalances, but the authors report adequate randomization methods, questions 1.1 and 1.2 should still be answered on the basis of the reported adequate methods. And any concerns about the imbalance should be raised in answer to question 1.3 and reflected in the domain level risk of bias judgment. Trialists may undertake analyses that attempt to deal with flawed randomization by controlling for imbalances in prognostic factors at baseline. To remove the risk of bias caused by problems in the randomization process, it would be necessary to know and measure all prognostic factors that were imbalanced at baseline. It is very unlikely that all important prognostic factors are known and measured. So, such analyses will, at best, reduce the risk of bias. If authors wish to assess the risk of bias in a trial that controlled for baseline imbalances in order to mitigate failures of randomization, the study should be assessed using the Robbins I tool. Again, you have to choose between yes, probably no, no, and no information. After you've done all that, click the algorithm button, and you can also make your choice, low, high, some concerns, based on your previous answers. You can either agree with the algorithm or give a different answer. Suggested risk of bias judgments can be overridden if the review authors believe this is justified. For example, the importance of allocation concealment may depend on the extent to which potential participants in the study have different prognosis, whether strong beliefs exist among investigators and participants regarding the benefits or harms of assigned interventions, and whether uncertainty about the interventions is accepted by all people involved. In the next slide, I will describe how the algorithm works for this domain. Subsequently, you can give a judgment about what is the predicted direction of bias arising from the randomization process. Not applicable, favors experimental, favors comparator, towards null, away from null, unpredictable. This is your judgment as to which arm overall might benefit from any biases you observed. Before you move on to domain 2, you need to click the algorithm result button for risk of bias arising from the randomization process. What it's doing, and what you would have to do if you choose to use the word template instead of the Excel macro, is to follow the decision tree. Selection of the reported results, because you'll fall asleep and I will lose my voice. But I'll show myself going through the first one when I do it live. Low risk of bias means the study is judged to be at low risk of bias for all domains for this result. Some concerns means the study is judged to raise some concerns in at least one domain for this result, but not to be at high risk of bias for any domain. High risk of bias means the study is judged to be at high risk of bias in at least one domain for this result, or the study is judged to have some concerns for multiple domains in a way that substantially lowers confidence in the result. Finally, you also optionally answer what is the overall predicted direction of bias for this outcome. Favors experimental, favors comparator, favors null, away from null, unpredictable, or not applicable. To enter another assessment, enter a different assessment ID to create a new assessment and repeat the process that we've gone through. So once all that is done, the last thing we need to do is resolve discrepancies between members of the pairs of reviewers. Once that is all done, last thing we need to do is resolve the discrepancies between members of the pairs of reviewers. Fortunately, like SR Accelerator has Disputatron, the Prisma 2020 macro has Discrepancy Check. This facilitates the discrepancy check between two reviewers' answers and allows the output of agreed final judgments. The two reviewers should enter their assessment into different Excel files. It's important to back up your results, the first reviewer's results, before using this function, as the first reviewer's results will be replaced by the agreed judgments. To set this up, firstly, copy and paste all of reviewers 2's results from their sheet called results into the check sheets. This is harder than it sounds. If you aren't used to pasting whole sheets into Excel, select all the data in the worksheet. Keyboard shortcut is press Control and Spacebar, then press Shift and Spacebar. Copy all the data on the sheet by pressing Control C, then click the first cell in the new sheet and press Control V to paste the data. Then, and this is vital, ensure that the same assessment IDs have been used for the assessments of the same results in both reviewers' results. It's called Unique ID in the check sheet. When that is done, click the Discrepancy Check button on the intro sheet. A user form should appear. Both reviewers' answers should be displayed side by side. Judgments will be coloured in red if the judgments reached by the two reviewers are different. Once you've reached consensus with the final decisions, click Save and Close, and you need to go to the bottom of the screen and click the Intro tab. Then, once you're back on the tab with the button macros, click the Summary button on the intro sheet. This outputs the details of each assessment: assessment ID, study ID, reference, outcome, result, weight, plus domain level and overall risk of bias judgments. It also outputs risk of bias graphs that illustrate the proportions of results or information at low risk, some concerns, or high risk of bias for each domain. All assessments should appear in the summary sheet. A plot of the percentage of risk of bias assessments at each level of risk of bias per domain will be displayed on the right-hand side of the sheet. The default setting results in equal weighting for each study. The plot can be interpreted as showing the proportion of results at each level of risk of bias. If weights have been entered, such as sample size, the plot is weighted by this and can be interpreted as the proportion of information at each level of risk of bias. Next, go to the bottom of the screen and click the Intro tab. Then, once you are back on the tab with the button macros, click the Figures button on the intro sheet. This outputs Cochrane-style risk of bias figures, called traffic light plots, which display the domain and overall judgments study by study. Figures are displayed separately according to effect of interest, so assignment to intervention or adhering to intervention figures will be produced in the figures ITT, which is the one we'll want. Figures can be further edited, for example, by adding borders and lines using normal Excel functions before being copy and pasted into your manuscript. It's suggested pasting as a picture to avoid distortion in the format. A separate button in each figure can print figures and save as PDFs. Note, you can change the order of the studies in these figures by sorting the results in the results sheet. Finally, Generate Print View outputs the full study results for each study assessment, including the answers to the signaling questions and the justification given for the answers into a template. This can facilitate double checking, but it's vital for the creation of supplementary materials for publication. Click Generate Print View on the intro sheet, and the results will be copied and pasted into the Print ITT sheet. You may now need to adjust the width and height of the columns and rows to accommodate text use for justification of answers, and change the page breaks for printing if necessary. Okay, so I've got my risk of bias 2 macro open, and you'll see I've already said yes and given it all the permissions that are asked for in the yellow bar across the top. And the first thing you want to do is click the risk of bias 2 assessment form. And you can see here I've already populated these forms, and I've put a couple of examples in. Forgive me, the examples I've given are fairly facetious. For example, in assessment ID, I haven't followed the advice and put the details of the output and the details of my name and all that sort of stuff in there. I've just put one in. But you can see assessment ID is where you put that record number in that lets you identify that it's the record number and the output that you're interested in. Put my initials in, I've said it's study ID 1, I've given it a reference, I have under experimental described what the condition name is that I'm interested in, and I've just given the comparator condition a name. I've specified the outcome that I'm interested in, under specify which outcome, and I've specified the numerical result I'm doing this risk of bias about. Under the question, is the review team's aim of this result to assess? We need to click assignment to the intervention. And under wait for analysis here, I've weighted it as 1. So that's standard. But you're going to want to weight it by the total sample size so that the larger studies have a larger influence on the risk of bias. So for example, here I could put 100, and let's assume that study 2 had a sample size of 200. Now, in the weighting of the risk of bias chart, you'll see that there is more weight given to the results of study 2 than study 1. So that's what that does there, and you should do that. Okay. The next bit is which of the following sources were obtained to help inform the risk of bias assessment. I've clicked here journal article and trial protocol, but you need to tick any that you use to get information about the study. Once you've done that, then you're on to the domains. So the first domain is randomization process. And in this, you see the first question is, what was the allocation sequence random? Now, if you go into the general channel in Teams, you'll see that there is, under this week's class materials, under session 8, there is the crib sheet and there is this macro. So I'm just going to switch to the crib sheet, and here it is. And if you scroll down, you'll see for each signaling question, there's an elaboration. Now, that's why I'm not going to go through this whole document, because there's very detailed elaboration for each of the signaling questions. And what you need to do is keep this document open whilst you're doing the macro, and you shouldn't just rely on your first understanding of the signaling question. Okay. So I've given some responses here. I should have pasted in here the information from the full text that helped me come to that decision. And as you can see, I have to answer each one of these. And then I have to, this would normally be grayed out, and I would click. So let me just change that. You can see it changes as I click on it. Okay. And now you can see the effects. As you'll remember, 1.2, if you say that the allocation sequence wasn't concealed, it immediately changes to high, as we discussed. Decision tree. You can put any information here that supports your decision to do something different than the algorithm result, but I'm staying the same as the algorithm result. And here you have the option of describing what the predicted direction of bias is arising from the randomization process. So, for example, if I say allocation sequence wasn't concealed, if I say that the allocation sequence wasn't concealed, I can say that I think this would favor the experimental condition. So here we are on deviations from the intended interventions, and you'll see that some of these questions only become available depending on your answers. So you may have to answer different things depending what you respond. Okay. Again, paste in information where required, and then at the end you'll click this button and it will give you the algorithm result, and then you may, for whatever reason, decide to come up with a different answer. If you do, make sure you paste in supporting information, and again you get to describe if there is anything relevant that could cause you to have a view on the predicted direction of bias due to deviation from the intended interventions. Domain 3 relates to missing outcome data. And again, there are questions that only light up depending on your responses to the earlier questions. And after you've done those, make sure you click the algorithm result. Remember to put in the supporting information. And again, you can answer what is the predicted direction of bias due to the missing data. Domain 4 is measurement of outcome. Again, some questions only are highlighted depending on the response you give. Again, remember to click the algorithm result. Remember to paste in supporting information. And lastly, domain 5, what's the bias related to selection of the reported result? You have to answer all these questions here and give a response, and then click the algorithm results. If you have completed all the required questions, then when you go into domain, if you go into overall bias, all these will be lit. If any of these are grayed out, it's because you haven't answered all the questions. And then click the algorithm result, and you'll see in our case it's high, and my judgment is high. And I'll save that. Once you've done that, make sure you save a copy of this form, because the next thing we're going to do is paste in reviewers 2's responses into the check tab, so the check worksheet down here. And once we start doing a discrepancy check, the consensus that we come up with will overwrite my results. Okay, so I'm just going to show you how to do the pasting. You need to, first of all, we're going to imagine that I'm going into reviewers 2's results here. So say I'm in reviewers 2, you press Control space and then Shift and space, and the whole thing's highlighted, and I want to then press Control C to copy it. Okay. Now imagine I've done that on my computer, and I go back to my worksheet and I go into the check bit. Now I've already pasted it into here, but this would normally be blank, and you would go into the top corner here and just press Control V, and it will paste the results of the other reviewer in here. Once you've got the second reviewer's results pasted into this check section, then you go back to the intro tab and hit discrepancy check. Okay, and it comes up, and you need to go through each of the assessment IDs in turn and resolve discrepancies. So under assessment ID 1, you can see there is a discrepancy here, and we need to decide what to do. So consensus is my original responses, and response 2 is the other reviewer's responses. And whatever I change in here ends up overwriting the results tab, so it overwrites my original results. So if I change that now to yes and hit algorithm result, you see it changes. Now that is overwriting my results. Okay, so I need to go through the individual domains. You can see here there is a discrepancy, but I'm going to leave that as it is. Again, another discrepancy here, but I'm going to leave it as it is. And no discrepancy there. And under overall bias, I didn't change that. I need to remember to change the second one here. Now, I can change these, and we've got consensus there because I changed that first domain. Okay, let's assume I've done that in turn for all the assessments, and we've got consensus. I then hit save and close and go back to the intro. And the first thing I want to do is hit the summary button. And now I will have this summary information in here. And that's useful because I now, at the far right, have plot of percentage risk of bias for each domain. And if I'd weighted that, as you can see, I only had 2 assessments in my example. I left the weights at 1, but if I change those weights, it would reflect it. The one that we're interested in is percentage as intention to treat, and you can see up here the scores up here. Okay. Right, next I want to go into the intro view and hit figures, and this produces the Cochrane style traffic light plots, and you can see those there. And if I want a PDF of them, I can do that and then save it and cut and paste them into any document. Okay. Lastly, I want to click generating a print view. And now if I go to print ITT, you can see I've got the results here that I can put into an appendices. So that's how you use the risk of bias 2 macro. Now, This is another MF Doom quote, and it speaks to the attitude that you're going to need to have while making your judgments. And the key bit is type just to blank and don't show much pity. And I think that speaks to kind of be dispassionate about it when you're making these judgments. So what are the action points for this week? First of all, you need to make sure you've finished all data extraction for the included studies. While you're doing that, you can do the risk of bias 2 extraction at the same time. This is easier than waiting till you've got it all finished, because then you'll be really familiar with the paper. Okay, that's everything for this week. I will see you next week for session 9, where we'll be looking at the write-up process.